So one of the interesting things in First Tech Challenge is the teams actually start their season in September, and then they get to try their robot at their first league event in November, again in January, and then they come through to championships. It means they go through the engineering design cycle 3 times throughout the season. So it's a really good chance for them not just to see what works and doesn't work, but they get to see what the other teams are trying and what works and doesn't work. So there's a whole lot of learning that is going on as they build on all their successes throughout the season. Every team has its own characteristics, and some mentors are very involved on the technical side, and some mentors choose to encourage the kids to take on a more technical role. So again, this is one of those things, every team finds its own way. We also find that a lot of the teams, because we have an open kit of parts, they're allowed to 3D print, they can laser cut, they can machine parts. So some teams, the mentors will take on very much of what I would call is like a true machining mentoring role, where they're teaching the kids these really amazing skills for how to create their own parts for the robots, as opposed to the mentors actually creating the parts for the robots. So it's a really neat opportunity for them to actually envision something. Teams will use CAD to actually design the part, and then they transfer it from there into the machine that actually generates the part. I think it's a fantastic thing to do. Your students are going to learn, they will be picking up what you would think of as engineering skills. It's a chance for them to actually see how math is applied. We've had a number of our team members this year who are beginning to start using things like the gearing ratios, and they're having to figure out when a robot wants to lift, how much power does it need, and how does motor torque turn into actual lift on a robot. And that means that the theoretical learning in the physics classroom has just become applied, and suddenly they're more motivated. One of the students I know has done a lot of testing with sensors, and she's looking at actually graphing her results and coming up with a line of best fit and how to adjust the sensor values, because the raw data values aren't always exactly what is the reality in life. And she's learning that, oh well, up to a 30 centimeter distance, I have to multiply by this constant, and after 30, so there's a lot of really interesting learning that can go on.